Okay, we're going to do the same thing that we did yesterday, except it's just slightly different. What do you notice is different about example 2? Yeah, remember before, here's what you had. We said, f of x is equal to, say, x squared minus 3x. And what we said is that you wanted to find the width of the intervals, and then you needed to find the heights. What did we do to find the heights yesterday, remember? We took the x values and plugged them in there, right? Well, this tells you what you get if you plug them in. You see that? So it says, use the following table to determine the approximate area bounded beneath the function over the interval -2 to 6 using 2, 4, and 8 rectangles. Well, if I'm going from -2 to 6, I'm using 2 rectangles. What's the width of each one? The width is 4, right? So I have 4 times, then I need the sum of the heights. So if the width is 4, okay, this is a width of 4, right? And then this is another width of 4. So right now we don't have that picture that we're looking at. So we have to think about it. Right now, we haven't talked about left hand, right hand, midpoint, trapezoidal, all that business. Right now we said we're always going to draw to the right or the left or what? Always to the right. So if my subinterval is from -2 to 2, do I draw the height at -2 or +2? I draw it at +2. And what's the height at 2? 7. Then 6. You can see in this situation, I get 4 times 13, which is 52. See if you can do 4 rectangles on your own. Go. 8 rectangles. So 4 rectangles should come up with 44. If you do 8 rectangles, what's the width of each one? Just be 1. And as you look here, our first interval, and again, you're going to evaluate the height at -1, which would be 10. So you can see I start with 10, and I move on forward all the way down this row, and I connect all the way over to 6. And anybody add that all up? What did you get? 58? Okay, 58. Great. All right. So that's the estimated area. So one thing that's interesting to note is that we had 8 subintervals, but how many numbers are up here? 9. That's because, you kind of need 9. Because you kind of need a number on each end, right? Like, for example, 1 to 2, that's one interval, but there's 2 numbers because it needs a beginning and an end, right? So that's kind of how that works, okay? Yeah, so really interesting question. So Maya sees it and she's pointing out, she kind of said, you know what, 2 rectangles gave us 52 and 4 rectangles give us 44. She was expecting this to probably be something like, say, 41 or something like that, right? Kind of hone in on a certain value. Well, if you look at it, it's a really crazy behaving function. Like it's at 5, then it goes up to 10, then it quickly drops to 1. Then it goes up to 5, up to 7, up to 16, down to 8. So functions that behave like a nice smooth curve, generally you're going to see that happen. If we increased it to say 1,000, you would see it definitely hone in on one number. But right now, we just don't have enough rectangles to really see it kind of move in. You know what I mean? If you're thinking about it, when you're thinking of it kind of going towards a certain number, you're thinking of the limit. Was it approaching? Yep, it's all connected to that. So our last example for the day, and then you're going to have time to work on your worksheet. Use the following table to determine approximate area bounded beneath the curve or the interval 0 to 8 using 2, 4, and 8 rectangles. So we don't have a function, so we are just going to estimate. We are just going to estimate. I have 2 rectangles, so what's the width of each one? The width is 4. So this is my first subinterval. This is my second subinterval. Do I draw the height at 0 or at 4? I draw it at 4. And I, just go over to whatever it is there. Let's say maybe about 9. And then I draw the next one, I draw it at 8. And so would you say it's an underestimation or overestimation? I would agree it's an underestimation. It looks like when you see the area, it's represented as under. Good for you. So we have the width, which was 4 times the sum of the heights. And the height, what are you going to say is the height of the first one? 9. Plus the height of the next one? 3? Sure. I'm going to go 4. And it's okay. I want to be clear. This is an estimate. So, 3, 4, 5, those would be fine. If you said 10, that would be wrong. All right. So, and I get 52 out of that. So we'll do 4 rectangles. Well, if I do 4 rectangles, what's the width of each one? Very good. The width is 2. So I draw the height at 2. Then I draw the height at 4. Draw the height at 6. And draw the height at 8. So those are my rectangles. So 2 times, what numbers would you like to use now? 9? Okay, we'll go 8.5. Because we multiplied by 2, it'll become an integer. That's kind of fun. Next one, we'll go 7. And then we kind of decided to use 4 before, didn't we? The way I drew it now, it actually looks closer to Ishika's 3, doesn't it? So, should we go 3.5 to kind of appease the world there? All right. So we would say, graphically speaking, to get to Maya's point, we would say that this is a better estimation, would we not? So we should see it kind of closing in on a better value. We just really couldn't see that with the table, could we? But this, you can see that it gets better. So 8.5 and 3.5, that adds to 12. And then that's 16. So that's 28 times 2. My math goes 56 on that. Okay. All right. And then the last one, what's going to be the width of each one? Just 1. And so I'm going to and it really is okay to, really just make estimations here. I think we would all agree that that's a better representation. It really is. I'm going 3 9s on that just to start. Got 1 times 9 plus 9 plus 9. Then what do you want to do? 8.5? Sorry, Riker. But you can call my worksheets packets, so I'm going with other people. So how about there? What are you going with? Okay, I like 8. I would go with 8 then. 7. 5. And then we're using Ishika's 3.5. How's that? So 8.5 and 3.5, that makes 12. And 14 makes 26. 16 makes 42. 17 makes 59. So yeah, you can see it seems to be kind of closing in. So again, the basic concept over the past couple days I want you guys to understand is that drawing of rectangles, identifying the width, knowing where you draw the height to, and going from there. Next week, we're definitely going to get more complicated, but make sure that you can own this worksheet and feel good about it. So you got the rest of the time to work.